Imagine walking into your favorite department store. You just got a bonus at work, and so you have a little extra cash in your pocket. You start picking up all sorts of things that you might like to buy. You take these items into the dressing room and you begin to try them on. The things that you really like, you go ahead and put those into one pile. The things that you don't like or they don't quite fit, you put those in another pile. And the ones that you're on the fence about, they go in this third pile. Now imagine this mirror is actually a smart mirror. And it's been observing your decisions, so much so that it can now offer recommendations to you of other products in the store that it's pretty sure you would like. There's even buttons on the items, so you can click it and a sales clerk will bring you that item in your size. Pretty cool. What's really cool about this, though, is that the technology for such a system exists today. So my question to you is, how would you test this? Take a moment, think about it. Would you even know where to begin? There's a lot of smart people in the field, people who I admire and respect, who are talking about the future of testing. People like my good friend Paul Merrill. Paul says machine learning won't necessarily eliminate testing jobs, but it will change how the work gets done. The World Quality Report says we believe that the most important solution to overcome increasing testing challenges will be the emerging introduction of machine-based intelligence. And the founders of Applitools, one of which is here today, says we'll see a trend where humans will have less and less mechanical dirty work to do with implementing, executing, and analyzing test results, but they will still be an integral and necessary part of the test process to approve and act on the findings. All of this sounds amazing. It's very exciting to know that AI tools exist and more are coming to help us do our jobs better, help us to test. But there's a nagging voice in my ear, probably the tester within me, that's saying, well, the AI is helping us test, but who is testing the AI? And I've consulted with a lot of teams. I've heard a lot of stories of people who they have AI-enabled features. And when it comes time to deliver these, the tester asks, okay, do we need a test plan? And everyone says, oh no, that's the AI feature. And everybody goes, oh, okay. And we treat this as this all-knowing black box of magic that just works. I don't know about you. I watch the news. This stuff doesn't always work. There's been some terrible stories, right? In fact, just a couple of weeks ago, DHH, famous software developer, he tweets out, he's very upset with Apple because David and his wife, they're both millionaires, by the way, right? They apply for an Apple card. And when they apply for the card, they both get approved, but David's limit is 20 times more than his wife's. And so people start speculating. Well, she probably doesn't make as much as you. He says, no, we file our taxes together. On paper, we have the same income. They said, well, her credit score must not be as high. He calls Apple. They tell him the same thing. Oh, no, it's the algorithm. We're not sexist. The algorithm has to be correct. So David, fed up, he goes ahead and he orders a report of his credit and his wife's credit. Guess what? His wife's credit is higher than his. And yet his credit limit was 20 times more. He calls Apple again. I'm sorry, sir. You don't know what you're talking about. The algorithm decided this. It's correct. They escalated it up to management. No one could tell him how this algorithm works. But everyone assumed that this had to be correct. They couldn't process that this was not correct. The algorithm could be wrong, right? Now, this is a disturbing story in itself, but what really bugs me about this is how confident people are in the algorithm that they've never even seen. And I began to wonder, how did they test it? They probably didn't. If you have this much confidence without looking at it, why would you test it? Right? And this is problematic because these applications are becoming more and more prevalent. We see more and more everyday technology that we use that's using AI. Anna went to Best Buy and bought dozens of products and toys and gadgets and brought them to us last night. A lot of them were AI enabled, right? So this stuff is very common. How are we testing this, right? Let's look at some everyday applications. Netflix. How many people use Netflix in the room? Just about everybody. The very first page that you are on when you go to Netflix, this is driven by machine learning. These are recommendations for you. Now, 80% of what we watch on Netflix is because of the recommendation. So it's pretty important to Netflix's business model that this is correct. But what is correct? What does correct mean here? I know myself better than anyone else. I can't look at my Netflix page and tell if it's correct or not. I took a harder try and I looked to see if anything stood out to me. Now, most of these shows I've not seen, so I don't even really know. But this one in particular, I thought, well, this looks wrong. It's a show called Beyond Stranger Things. Who here watches Stranger Things? Lots of people. I don't. I've never seen a single episode. So I was wondering, well, what is this Beyond Stranger Things? And so I went to Google, and Google told me that this is a show that talks about what happened on Stranger Things. And there was actually a disclaimer there that says if you haven't seen Stranger Things, don't watch this because it contains spoilers, right? So clearly this is wrong, but that's all I got here. I don't know about the rest. Twitter, I used to work there up until last year. Twitter uses machine learning for lots of different things, one of which is to detect spam on the platform. So let's say you had a tweet that says something like, message us if you're looking to buy some followers, $2 per 1K. This is clearly spam, right? But how do we know that this is spam? Is it because of the words that are being used here? Because we have a similar tweet, same words that says, hey, wannabe celeb, you have a total of 2K fans. Why don't you go buy some followers? Now, this is rude, but not spam. So how will we test for this? Watson, IBM's AI engine. Watson is brilliant, right? Watson can do all sorts of things, one of which is make amazing brownies. So I went to a conference a couple of years ago, and IBM had a booth there. And they were bragging that their super AI computer had reviewed thousands of brownie recipes around the world and had come up with the perfect combination. I won't ask you to test it. I did this favor for you. All right? It passed. Test passed. Best brownie I've ever had, right? It was so good. It had a little hint of cherry, little liqueur, very good brownie. But Watson also does a lot of other amazing things as well. like in healthcare. So, given a cancer patient, Watson can analyze millions of pages of clinical trials and medical literature to be able to come up with a customized treatment plan for that patient. That's pretty impressive, but how do we test that? It's not something that we can get wrong, right? Now, I could stand before you today. I could give you a bunch of theory on machine learning. I could give you some terminology and some jargon. But I think that I'm most effective when I share my experience with you from the trenches. And I've actually tested machine learning before. So I would like to share this story with you, if that's okay. Cool? All right, let's do it. So once upon a time, I worked at a company that made an advertisement recommendation system. And this worked with third-party companies, mostly e-commerce companies. So the e-commerce company would send us their entire inventory of ads. And when they were interacting with a customer in real time, then they would make an API call to our service, giving us some information about this customer. So maybe they would send demographics like, oh, this is a 21-year-old woman. And so our system would then provide a recommendation of which ad they should show to that person. And the key ingredient here was machine learning. So it would learn who interacted with what. So the e-commerce business would then send another API call to us saying, yes, they like that one, or no, that didn't work. And the system would continue to learn on this. So the idea here is that it would get better and better over time, learning who likes what. So I had to finally answer this question of how do you test this? And let me tell you, I didn't know. At this point in time, I hadn't even heard of machine learning before. This was all extremely new to me. So I began to do some research on machine learning, and I found a lot of information about what it is, but not any information about how do you test it. So I had to come up with my own plan of action, and that's what I'll share with you today. So the very first step to testing machine learning was to learn how it learns. Now, I believe that we could not answer those earlier questions about the Netflix and the Twitter and the IBM because we have no idea how those systems are learning. So I needed to figure out, what are the rules here? What does our system do? I consulted with the developer and asked him to explain to me about machine learning and how it works. Now, this developer, we'll call him Resident Expert. Resident Expert, brilliant guy. He was the only one in-house who even knew about machine learning. No one else. All the rest of us were clueless, right? So he was leading the charge here. And he's one of those guys where you talk to him and everything he says is like really big and complex and kind of over your head. Yeah, that kind of guy. So I got as much information as I could. A lot of it was still cloudy, but what I did learn is, okay, for number one, the system, if it doesn't know anything yet, like it's brand new, it would just send ads randomly until it starts learning. Once it starts getting information back, it's learning by the customer sending us that API call, letting us know, yes, the person accepted that ad, meaning they purchased the item, or no, they didn't accept that ad. They would send that information, and this is what the system was learning on. Now, it would generate these models, and the models were basically knowledge bases. So it would generate models about different types of customers and different advertisements to be able to get the information. Once it learned this stuff, it had the models, it then would consult these models to make future decisions. So it should get better as it has more and more information, meaning I need to send a lot of test data here, and I need to test it quite a bit. So just saying like one simple scenario of, this 21-year-old woman accepted that ad, that's not enough to speak for all 21-year-old women, you know. This makes sense when you think about it. So the more and more data it has, the better it is. The other thing that I learned is that the outcome is not deterministic. Now, this was a big one for me as a tester because I grew up on the notion of if something was not deterministic, you don't test it. You say, oh, that's not testable, right? And we would skip over that. For example, if I had a scenario where I'm adding a product to the cart, the item costs $20, we increase the quantity to 3, then the subtotal should be $60, right? This is exact, testable, automatable. Machine learning doesn't work like that. You're not quite sure where you're going to get, but there is this range of validity. So that spent my mind a little bit. So, okay, now that I knew how it was going to learn, the next step was to teach it some stuff. Now I need to train the system. So come up with what it is that you want the system to learn. What's the scenario here? And I had a very basic one. I want the system to learn that the women are more likely to buy a dress, if shown that ad, and the men are more likely to buy pants, if shown that ad. That's my scenario, and so now I need to train the system. To do so, I wrote a script. I sent 2,000 API calls. With the API calls, again, you send the demographics, right? So all I needed to send was gender here. So I randomly generated the gender in my code. So it would be about 48 to 50% of either gender. And then I had 5 ads. I didn't just want to do the dress and the pants. I threw in 3 more, really give it a really good live feel. So dress, pants, and 3 others. Now again, if the system doesn't know anything, it sends the ads randomly. So at first, as I'm training the system, then it should be sending things about like 20, each of these 20% of the time, which would be random. And I started off in my script. So I need to, as the customer, accept or reject the ad. I started off thinking, okay, anytime the woman sees a dress ad, then she'll accept it. And the same with the men in pants. But I thought that's not very realistic for somebody like, 100% of women accept the ads. And I didn't want to teach the system that sort of thing. So I reduced that to 65. 65% of the time that the women saw the ad, then they would buy the dress. And then 65% for the men in pants. And then 2% of the time, I had the user accept the ad no matter what, no matter their gender, no matter what the ad was, because we needed to generate these models. I needed the system to learn about all of these ads. And I wanted some men to buy dresses, some women to buy pants, just to mix things up a bit and be more realistic. All right. So this is the script. Also in this script is a complex data structure which mimics this. So I ran the thing 2,000 times. The women who saw the dress ad was about 200 on each of these. So that's the random. That worked great. And then I needed to accept, right? So of the 202 women who saw the dress, I had 133 of those women to actually go on to buy the dress, and very small, 3 or less for all other 4 products. For the men, also 200, perfect. And I had, of the 196 men who saw the pants, 128 of those guys actually went on to buy the pants, and 3 or less for all the others. So now the system is trained. We have it all set up. Third step, Test it. What do I do? I was lost at this point, right? Especially because I'm automating this. I have a script. Again, with that deterministic. I'm ready to write an assertion here. But what do I put in the assertion? I have no idea what I'm going to expect. So I go talk to resident expert and say, yeah, I need to write an assertion. I understand range of validity. What's the range? He goes, I don't know. Nobody knew. So I used the POX method. The POX method is plain old common sense. POX method tells me that if before learning anything, it would send the ads out randomly, 20% of the time, each one was 20% of the time, then after it learns something, then the dress should be shown to the women more than 20% of the time, and should be shown to the men. The pants should be shown to the men more than 20% of the time, and everything else should probably be less than 20%. That's all I had to work with. So I put this in and figured I'd see how it goes and update my script accordingly. So I ran the script. So excited. All right, so there were 202 women who saw the dress before learning. After the system learned, 890 women saw the dress. So yes, I'm kicking butt. The system has learned that the women like the dress. So then I look at the poor guys. 196 men saw the pants before learning, but now only 59 saw the pants after learning. That's not right. And then I looked at the dresses for the guys. 204 saw the dress before learning, and 874 saw the dress after. So I thought, what did I do wrong here? I know I messed this up, right? My confidence was shot very quickly. I was so excited when it ran at first, and now all of a sudden, I'm back to square one. So I was really confused here. I began to look at my code, try to figure out, like, where did I go wrong? What did I do wrong? Obviously, I didn't train this thing appropriately. And so I deleted all of the models, and I reran the script. Any automation folks, you know we love a good retry, right? So I reran the script. This time, I got different results. So after rerunning the script this time, the men did get the pants more, but so did the women. So now I'm really confused. Delete the models again. I looked through the code line by line. I said, I did learn that it needs a lot of data. It must not have a lot of data here. The 2,000 must not be enough for it to pick up a pattern, right? So let me increase that. I changed that to 10,000. Ran it again. Same thing, flip-flopping. Sometimes everybody gets the dress, sometimes everybody gets the pants. So deleted the models again, ran it again. This time I said, let me output those data structures so I can do some comparisons here. When I did this, I figured out what was going on. Because I was randomly generating the gender, it was never 50-50. Might be 52 women, 48 men, or 49-51, something like this. Whichever gender had the most people, the system was learning that because of their purchases being more, this was the most popular item. So it wasn't learning on gender at all. It was only learning based on what was the most popular item being purchased. And I thought, wow, I found a bug. I found a bug, y'all, in machine learning. Can't tell me nothing. So I began to open this bug. And this is unlike any bug I've ever written, right? So I'm used to writing a bug. You know, you put your expected result, put the actual result. If I'm feeling very generous that day, I might throw in some screenshots and some log files, you know. But this one, there is no expected result. Who knows what's the expected result, right? So I basically had to write this paper of how did I train the system? You know, what is it that I taught it or think I taught it? And what did I expect it to learn? And how is it deviating from that? Why is it not in this range of validity here? So it took me quite a while to write this up, a couple of hours actually. And, you know, for all my hard work, I opened this at the highest severity possible because it's a pretty bad bug as well, right? So I opened this bug up, feeling great about myself, and resident expert gets the bug. He reads over the report. He closes my bug. And he says, well, it works on my machine. I couldn't believe it. I go to his desk, right? My ego is bruised a bit, but I'm like, whatever. I go to resident expert's desk. I say, okay, it works on your machine. Can you tell me where I went wrong or whatever? And he says, well, and then he starts hitting me with all of his theory and his fancy jargon about machine learning and how it works, right? At this point, I'd had enough of this day. I go home. I figure I will sleep on this. I will come back tomorrow with a fresh brain and fresh set of eyes. I come back the next day after not even being able to sleep really. This was really bugging me. But I come back the next day. I pull out my code. I start looking at it again. I'm deleting the models. I'm going line by line. I can't figure out what I've done wrong. I call my team lead over. And I says, yeah, resident expert closed the bug. I don't know what I'm doing wrong. I don't know why y'all put me on machine learning anyway. You know I don't know this. And he says, Angie, stop it. You've done the research. You know it. It's a bug. So I reopened the bug. So resident expert, he comments on the bug, again, with the theory of machine learning and all of his fancy jargon, basically saying that this stuff works. And I simply reply, it doesn't work. And we leave the bug open. And it stays open for quite a while. And I imagine anyone who's reading the comments of this is all over everybody's head. Only resident expert knows this stuff. And I have a semblance of a clue, right? But everybody else, this means nothing to them. So you read this and you read this guy's fancy jargon and you're probably thinking, yeah, he's right. And Angie doesn't know what she's talking about, but whatever. So they leave the bug until it's time to ship. Well, we can't ship with the highest severity bug open. So the product owner calls a meeting that looks something like this. So she says, okay, we have this bug open. What's going on here? Tell me, basically, plead your cases. So resident expert, he begins to talk. Let me tell you, when this guy talks, you believe him because he has really fancy words and stuff. And so he starts describing, again, the theory of machine learning and how all of this is supposed to work. I know I can't compete with that. So I don't even bother trying. I took a different approach. Instead of explaining to these people who know nothing about machine learning, about the theory of machine learning, instead of talking about models and the script that I wrote and APIs and data structures, I decided to just make it plain. I said, hey, listen, here's what we have going on here. We have customer, which is, let's say, clothing store. And they tell us, hey, I have a man here. Which ad should I show him? And even though men have purchased the pants 65% of the time, we think it's a great idea to keep showing the guys the dress ad over and over again, even though they're buying this less than 1% of the time. So the customer is going to lose money. We're not showing the best ad that's going to convert. But hey, you all do what you want. And I rested my case. Now, when I explained this in plain terms that everyone could understand, then you started seeing the ears perk up. And product owner turns to resident expert and says, run her scenario on your machine right now. He says, okay, pulls down my code. He runs it. Guess what? It doesn't work. And he turned red in the face and he says, I don't know why I doubted Angie to begin with. And that made me feel pretty good. So, what did I learn in this experience? I learned that as our technology advances, so must our test approaches. There was a lot of things that I was used to as a tester that were no longer so when testing this advanced technology. It challenged a lot of my beliefs and the way that I basically grew up in this industry, right? So things that I would have just discounted and said that, oh no, that's not a testable feature. That can't be the case for every AI feature. We have to figure out how to test it. The need for automation became much more apparent, right? So there's a lot of discussion in the field about, do testers need to learn how to automate? Now, I'm not going to say you need to learn how to automate tests per se, but I do believe that as this technology advances, we all do need to know how to code. I had to write that script to be able to test this. I can't imagine trying to run 2,000 API calls by hand in order to train the system, right? Or, heaven forbid, pulling out an Excel spreadsheet and typing in the results from each API call, right? You would quit. Not only that, I had to send the customer responses as well. So double that, 2,000 turns to 4,000. And what about when I wanted to train the system with more data and I changed it to 10,000? This was as simple as backspacing on the 2 and typing in 10. But imagine the labor that goes into if I needed to do that manually, right? So definitely need to learn how to code. And coding is what I'm saying. So not talking about Selenium. There was no web interface here. I needed to straight up code, right? Understand logic and data structure and loops and all of that good stuff. All right? Now, while we do need to know how to code, there's still definitely a need for thoughtful and critical testing. Everybody wants to push the testers to learn how to code. Who's pushing the developers to learn how to test? We have resident expert who knows about machine learning, guru. He knows how to code. He was ready to ship this thing without the most basic of scenarios working. So we definitely still need to use our critical thinking skills. And plain old common sense still can trump an algorithm, right? So while resident expert gave his elaborate story about machine learning to the product owner, what won the day is just plain common sense. Listen, I know what you're saying. I know maybe programmatically you think that this works, but from a customer perspective, here's the outcome, and it's not good. Now, I don't believe in fighting for bugs just to fight for bugs, but I do believe in advocating for our customers. And so we have to keep them in mind as we're using these advanced technologies. Now, if this would have failed and remained broken and no one listened to my story and we shipped this anyway, we probably would have lost some money, a lot of money, lost some customers, maybe even went out of business. But in the grand scheme of life, it's not that big a deal. AI is being used for much bigger things, right? Like the healthcare stuff that we talked about, or the trolley problem, right? So the trolley problem, I actually heard Paul Fenwick talk about the trolley problem in AI at OSCON a couple of years ago. And he did this colorful job, so I brought Paul with us here today to explain to us about the trolley problem. So, of course, my question to you is, how would you test this? So you see, this is starting to get a lot more complex. And as testers, again, we need to be asking questions. That's our job. We ask a lot of questions. We make sure everybody understands what it is that we're building. We interrogate the system. We're question askers. So the questions are going to get a lot harder now. Like, hey, are we killing kids or what? And this is the type of stuff we talk about now in the meetings. Now, I'm going to take the children out of the equation for a moment. Let's make this simpler. Let's replace them with animals. Let's say like a deer in the road, right? And okay, so we have a deer in the road. Do we hit the deer or do we jump off the cliff, right? How many people say we sacrifice the life of animals for those of humans? How many people want to save Bambi instead? Oh, aren't you sweet? And how many people don't know? You don't know. All right. Okay. So most of the people said that we're going to sacrifice the life of animals for those of humans. So that's the consensus here. We're going to go with that, okay? All right. Everybody good? Right. So that makes sense. That feels good to me, except you have things like this that occur. Here, Google Photos identifies things and people. So black people had their pictures and Google identified the black people as gorillas. Now this seems like taboo and we could laugh about it, except when we think about this in the context of the trolley problem. So you mean to tell me that this AI cannot recognize people with darker skin and might mistake them or misclassify them as animals? So now we have dead black children in the road, which is what nobody wants, right? So you can see there's lots to look at here. Not just the functional aspect, security, privacy, ethics, bias, so much so. So when, not if, when you're faced with needing to test AI-enabled features, this is coming. When you need to test this, I don't want you to let anyone convince you that the system has become so advanced that it's beyond needing testing. We're not there. Okay? So my friends, the future is here. I beg of you to test it. Thank you.